Hi, everyone. My name is Sierra Young. I'm currently an assistant professor in the Civil and Environmental Engineering Department and Utah Water Research Lab at Utah State, and previously an assistant professor in the Bio and Ag Engineering Department at North Carolina State University. Today, I'm going to be discussing our work on developing and manipulating UAV for conducting controlled pollinations for the forestry industry. And just for context, loblolly pine is our species of interest for this project, and it's grown and cultivated, harvested for timber and paper products all throughout the southeastern US and many other countries and locations worldwide. So it is a timber species of great importance. And within both breeding programs to improve genetic material, as well as an industry to develop seed and generate stands of loblolly pine, controlled crosses are an integral component of those processes. And so for context, seed orchards that generate and produce seed for production, they currently, to control the pollination process, put millions of exclusion bags on trees every year, and they do this completely manually. So this is a video of kind of that in process. They use a pneumatic pollen injector. This is from the North Carolina Forest Service, and they manually go up into these trucks and inject pollen into every single bag to avoid contamination from ambient pollen. This is, of course, a very labor-intensive task and something that we think is possible to automate using manipulating UAVs. And so we have been developing for the past year or two a platform to achieve this. And we started developing first the manipulator and automatic pollen injector suitable for integration with UAV, and have since gone on to develop the autonomy and navigation to operate this platform within an orchard environment. And just for context, in these seed orchards, the trees are located a little bit far apart, so there is space for a UAV to safely navigate between these trees, and the bags are generally placed on the perimeter of the tree, making them largely accessible. So we've gone through several iterations first of our pollen injector payload for the platform. We started first with just a Stewart manipulator for orientation, followed by kind of vertical actuation of a needle with a pollen reservoir into the bag. This worked okay, it wasn't great, so we've since taken some bio inspiration from beetle pinchers and other games, and we've developed this claw, which actually works quite well. So we're still using that Stewart platform for orientation, and now we have a fast actuation of this claw system with a needle and pollen reservoir at the end, and that is capable of then puncturing the bag. And so this is now our validated prototype that we've worked with in a lab setting under a variety of orientations between the manipulator and the platform. So we're working with this now and integrating it into our platform. In addition to the actual payload, we're working on autonomous bag detection, tracking, and navigation to individual bags using both stereo, depth, and RGB imagery. So here's an example of what our in-flight stereo vision data look like. You can readily see the bags are visible, and we also have just a simple object detection identification model using deep learning network. And so these two combined give us the bag detection and also localization in space. And one thing that's interesting that we've been working on is detecting different bag surfaces because the injection is most successful when the bag is oriented in a specific way. And so we've been able to identify sort of the side surfaces and the bottom surface using point feature histograms, basically looking at the relationship between individual points and nearest neighbors, and looking at mean curvature around those points in multi-dimensions. And so this method is very good at identifying that large flat bottom surface of the exclusion bag from those gentle sloping sides of the exclusion bag. Which is information we will ultimately use when performing the pollen injection. And so this is, again, just an overview of our entire system and our workflow to go from kind of navigating to the tree, bag, and ultimately injecting pollen. To date, to summarize, we have a working proof of concept and prototype to actually inject pollen using a lightweight actuated manipulator. And we have now models for identification and tracking bags. And we've done this in a simulation environment just using ROS and Gazebo. And right now we're working on integrating these two different pieces to do our first proof of concept flight in an orchard environment in North Carolina this spring. And so I'd like to thank you for your attention and also acknowledge PhD candidate Piyush Pandey, who's been working on this project, who is in a dual PhD program in both bionet engineering and also the forestry department. So thanks for your attention. And there's our contact information.